Thank you to all our speakers and welcome back everyone to the main room. We will now deep dive in a fireside chat. Please allow me to introduce the moderator of the session, Andrew Tan, Principal Data Scientist at QuantumBlack and formerly of GovTech Singapore. Thank you all, and over to you, Andrew.
Thank you so much, Tran, for the introduction. Today, I'm super excited to have with me Syafri Bahar, Vice President of Data Science at Gojek, and Yetunde Dada, Director of Product Management at QuantumBlack, based out of the London office, for this fireside chat on ML at scale in e-commerce. I suspect we'll be spending a bit more time talking about ML at scale, maybe not so much about e-commerce, but let's get started. I'm sorry. So first of all, Yetunde, would love to hear from you as a Director of Product Management. How do the products you build help practitioners scale ML? And maybe even more fundamentally, what would you define as scalable ML?
Sure. When we have this mindset, we often have to look at what the pilot trap, for instance. So why are ML products failing to actually get into production? And there'll be a host of reasons that are related to obviously support from the organization, but there's a large component that actually looks at whether or not we've actually thought of analytics code as though it is a product and it is software. So when we look at the focus of our work in the product management space, a lot of it is actually looks at how we actually deliver software. Do we make code that is robust? Do we make the code versioned and monitored so that it is easy to debug when something actually goes wrong? And obviously with these things, we also have to think as well about end user adoption as well, and how we best support end users being able to think of those things. When we talk about code being scalable, there's different ways to think about it. There's one, does it scale to many more users? Because maybe you've been able to ship the model or ship the ML product at a smaller scale to a smaller group for testing. Or does it scale across different regions as well? Because maybe you're dealing with a multinational company and it needs to actually go to many different countries as well. Can we use the same code base? Can we use the same infrastructure in order to deliver that? And those are all questions that you'd have to ask in terms of how you want it to scale the actual product. But ultimately, having a base for thinking about software engineering principles and having a base for robust code does make it a lot easier to facilitate some of those things as well, which is why we really have to adopt the software engineering mindset and apply it to data science code.
Thank you. Thanks so much, Yetunde. I think, so on to you, Syafri. Yetunde mentioned the pilot trap where a lot of projects fail to make it into production, and we've seen that at some clients as well, perhaps less data mature ones. Syafri, at an organization like Gojek, which is probably at the forefront of implementing data science machine learning models, how would you say, what are some key best practices that have helped you guys avoid this trap? And also, how has that changed? I'm very interested to see how that's changed over the time you've been at Gojek as the space has matured somewhat.
Yeah. Thank you so much, Andrew, for the question. I think this is an interesting one, and it's a very interesting insight actually from Yetunde. I completely agree that one of the key actually in order to scale machine learning system or data science solutions will be basically to look at it as a product, basically, right? What are some of the characteristics of products? It means small iterations. It means that we need to basically focus a lot on the end-to-end integration testing, starting at the very beginning already. We want to make sure that basically a product engineers, especially in product-focused companies, right? We want to make sure that all the stacks actually can integrate into machine learning solutions. I think that's a very important one. We want to make sure that there's an established experimentations ability to do traffic splitting, something as simple as that, actually, to kind of randomize the experience of users, right? And being able to test variant of various models. And actually, we need to think about scalability as well, because it's really important. I think it will be a very different perspective when we deal with hundreds of thousands of transactions, for example, per day, than if we deal with a million transactions a day. The tech stack will be very different. And most often than not, actually, what the modeling part is even only 10 to 15% of the job. I think in addition to that, there are so many dimensions that what I also mentioned in my previous talk, right? We need to think about SLAs. We need to think about what are the fallback solutions, right? We need to think about load balancing. All these things will be key to make sure that the analytics can actually go live to productions, right? And I think one more thing that I want to emphasize would be really in the principle of starting simple, starting with a very simple heuristic solutions, basically. Do a very quick experimentation, because then that will test the kind of like end-to-end integrations, right? And start experimentations and really see whether there is indeed some values in doing a very kind of like a feature-based decision making. So micro decision making, right? And if we do see values in this heuristic, right, which if you think about heuristic, it's basically like a simpler model with 3 to 4 variables, right? And then we kind of scale it out. Then we add 100 or thousands of features inside, and then we kind of like incorporate machine learning solutions. But I think for us, it's really about focusing on the first 80%, making sure that it ships, right? And then going after for the remaining 20%, basically. Oh, maybe you also mentioned, you also asked about how that has changed, right? I think especially at Gojek, within my tenure there, we've actually learned it the hard way. So our first machine learning system actually took us like 1.5 years basically to kind of figure it out, like how to move it from conceptual level into kind of production, right? And then once we found out the pattern, we'll be basically like and now it's kind of like a more like we're just like following a template or cookie cutters. But actually, previously it took us quite some time until we figure out the right operational models actually. Yeah.
Thanks, Syafri. That's super insightful. So I think what I picked up was that we still need to do things at the pilot scale. We need to prove value. So you can't avoid pilots, but then the question is really about how to then scale it, productionize it in, I guess, a short amount of time as possible. And would love to get thoughts from both of you guys about what roles teams then need, right? Because Syafri, you mentioned a whole bunch of things, even SLAs, designing systems that operate at different number of transactions, different scale, right? Like what kind of organizational model, roles on the team do you see to be important? And would love to hear from Yetunde on this as well, both from a product development point of view as well as perhaps from the work you've seen with clients. Like what kind of models for personnel work well?
Cool. So I'll actually start, I think at the whole component, Syafri actually spoke quite nicely about it, that we still need to start small and we still need to make sure that we're solving the right problem for end users. And we still need to make sure that we're going to be seeing adoption of the final model that people trusted in the end. So you definitely do need a complete product team in order to facilitate that. We have seen growth in, I think definitely growth in the industries where technical product managers or basically data product managers are being hired in this space, specifically to help lead the teams, but that obviously requires additional roles as well. How do we incorporate design thinking into making sure that we have delivery of something that will get used at the end of the day? And then beyond also being able to think about how we quickly iterate and prototype through the development of the analytics model itself, we also need to have additional team members that will help think about robustness and coding standards, applying the software engineering best practice to the code so that once we have proven value, it's easier to scale that code as required. And then there are all kinds of like auxiliary support functions that will be needed that you wouldn't normally think you would actually have to touch, but it's because it's software produced by your company. I mean, how well does your legal team, for instance, support your initiatives for you being able to deliver this code? Is it that you have to go through 50 different checkmarks in order to publish a model? What does that look like? And then also you have to have a very close and strong relationship with your IT and DevOps teams as well. How do they support the compute required for the model to run successfully? And how do they support, is it that you need to think about what is the data infrastructure that this model is going to be pulling from for it to be successful as well? So there's obviously, they say that if you want to move fast, you go alone. But if you want to move far, you have to go with many. So you have to obviously think of those things within the organization, how well you have those different teams to support analytics at scale.
Syafri, would love to hear from you as well. And maybe you could also touch on centralization and decentralization. That's also a topic as well.
Yeah, that's an interesting one indeed. Yeah, thanks so much, Andre. And I think Yetunde actually like provided some useful insight as well, right? I'll probably take it from a different perspective. I would basically classified a basic organization, right? Like the very early kind of like a startup entrepreneurial kind of like a model. And then like when an organization actually is mature in terms of data infrastructure, right? At the very beginning, what we found to be a very successful, really about like centralized models. And the reason for that is because it really allows us to kind of like run very quick POCs, being able to learn from like each other's learnings actually, while discussing with the stakeholders, while deploying our IT infrastructures and so on and so forth. Right? And I think what's also the things also about like a centralization model, because like it basically allows the kind of the idea of the central analytics, center of excellence, right? So basically we will be able to kind of like gain all of those insight and kind of like propagate it properly. That's one thing. And I think the second thing as well, it will actually reveal flows in our foundations, which I think is very important, right? Because once we do POC, maybe we're thinking about like a deep learning and stuff like that. But when we talk about our data, maybe the lineage is not there, single version of truth is not there, data quality might be really bad. Maybe we don't have like a scalable infrastructure. But I think by running it in a centralized manner, we'll actually be able to reveal some of these foundations, basically give us a list of things that we need to work before we even think about scaling the machine learning system, right? So that's one model. And as organization gets mature, I do see advantage of like getting very close with products, actually, like in product engineers, like really organizing them as a one team. Typically the way we do it, because I think the kind of like a natural movement will be actually to move into microservices, right, versus monolithic. So basically the way we do it, to organize team around microservices. It allows us actually to have a faster iteration, right, while still appreciating the different pace and sprint cycle that we have. If we compare it with like product engineers and data scientists, right, we have a lot of like data dependencies. So our sprint cycle kind of like a different if we compare it to product engineering counterparts, basically. Well, they have a typical like a very fixed. It's very easy. It is very predictable compared to like the way we do like data scientists, right? Sometimes you do a fast iterations and stuff. So really like having an embedded a structure which basically comprises of like product managers, engineers. We also have the data warehouse folks, data engineers, data scientists, even decision scientists in our case, really help a lot in order to kind of like build a very robust use case, especially to scale the product, right, machine learning system that we have. Yeah. I hope that answered the questions, Andrew.
Yeah, certainly. I think, and one interesting point I picked out was also how you mentioned that the cycle, it may not fit into a neat sprint cycle for data science work versus say product engineering development. Perhaps not, a bit underappreciated these days, but I find that to be very true as well. We've gotten a number of interesting questions from the audience. Maybe we'll take this first and see if we have time for other questions I've got for you guys. But the first one is about experimentation. And would love to hear from you guys about experimentation cycles. How are they getting shorter these days? Are they not getting any shorter? What's needed to build good experimentation cycles? And are there even any heuristics, for like how fast you try to complete an experiment or implement an experiment? Maybe Syafri on this one.
Yeah, sure. I can start with this one, right? So I think experimentation is actually I really think that it's an underappreciated subject, right? It is actually very important for us, because in order to kind of understand, to hit the jackpot, right, what will be like the right levers to pull to achieve certain business metric, we really need to do hyper experimentations, and it is actually within our gene. It was actually also our co-founder actually has done a good job in order to basically nurture these genes of experimentation, right? We are actually really encouraged to fail fast, but iterate also like faster, right? On that one, right? So experimentation, I think for us is really key. Talking about the experimentation cycle, so I would actually again divide it into like several steps and several phases, right? At the very beginning, for us, it's all about kind of like try to understand the consumption pattern, because again, like a different part of products might have a different maturity, right? So like the pace of the experimentation might be very different. We have, for example, products where it took us a couple of months to experiment, because it's just not very easy to stitch all the various components of experimentation, right? But we also have a product where we do exploitation, exploration at the same time, when we think about like a contextual bandit or reinforcement learning mechanism, right? Or even causal machine learning. This is kind of like the way we approach it. So it varies a little bit differently, but what we try to do in all aspects of experimentation is like we like to automate things. I think we're very obsessed about automation, right? So first, understanding the consumption pattern. If we can automate a couple of things, for example, to codify the statistical test that we need to use, right? We want to allow our product managers or business counterparts to just basically like put some inputs, and then they will automatically get suggestions in terms of what tests they need to use, or even automated experimentation analysis. So I think those are the product, and I think we also need to run experiment as product as well, because only by that, I think one thing that I really like about Jeff Bezos once said is that growth of a company is a function of the number of experiments that they do, which I really like a lot, right? Which this is really like I think for us it's really like a key. So we shouldn't underappreciate experimentation actually.
Thanks a lot, Syafri. That was insightful, and certainly sounds like you guys have a lot of different kinds of experiments going on, of very different natures. I want to shift gears a little bit to talk about open sourcing, because I know this is something Gojek has done a bunch of, and very active engineering blog, as well as QuantumBlack. We've done a fair amount of this with Yetunde leading a lot of this work. Would be great to get a sense from you guys. How has open sourcing these data-related products helped to drive adoption and scalability as well, if that's the correct way to look at the decision to open source?
I actually think open source is actually just a channel or a way to reach your users. And we obviously know that there's quite a bit of, there are many developers out in the world that can easily access open source technology. And there's obviously been, over the past few years, like a growth in the trust of open source technology that we may rely on it. So a lot of like companies around the world are definitely choosing to use open source technology, and our users are there, if that makes sense. So I think what really has been quite exciting to see in the industry as well is, especially for thinking about scalable analytics code, there've been a host of new products that have been created that basically are basically applications of software engineering for data science. There's a host of new stuff on monitoring. There's a host of new stuff on versioning. There's a host of new stuff on tasting as well. And this is across the different things that would make up an ML product. Your thought around data, your thought around the model, and the thought around the code as well, because you have to look at those things as different and interconnected components which make up the whole thing. So I definitely think open source is definitely helping drive adoption of these things, because it is a very easy channel for end users. It's one that provides you with a model of support in the sense that there will be big communities around the project. And it's also one that you can definitely rely on for continued upgrades of the software as it becomes even better. And the third one, I guess, is even that because it's community driven largely, you definitely get to have, I think, input as well with how the product develops over time as well. So you being able to help factor in and help get your specific problem solved with the software, I think, is a very exciting thing. I have, Syafri, I am a big fan of the projects by Gojek. So it's always been, I think, quite exciting seeing you work on Feast. So, yeah.
Yeah, I can maybe add a couple of sentences on what you had mentioned, right? So I think for us, there are two things basically, right? So number one, I think we're all about leveraging collective intelligence. I think that's always been our origin as well, right? And by kind of open sourcing our software stacks, right? It's really kind of like being able to patch things up and to kind of like improve, like move the quality of the software to the next level, basically, because we're talking about thousands of people basically like working on this together. So that's number one. I think number two is also about giving back to the community, because within Gojek also we use a lot of like open source technologies anyhow. So I think it's just only fair. And yeah, I think go far, go together. That's what Yetunde mentioned, right? And in this, I think just to kind of like give some overview. So we've actually also like open source on Open Data platform. We have around like 30 tools, libraries inside of there. That's also the case for our data science platform. And so we are really like a believer in open source. Yeah.
Awesome. And there's so much development going on in the open source space. And bring it back a little bit to, I guess, scalable machine learning, or scalable AI. What are some of the latest trends you're seeing in this space? Is it auto ML? Is it low code, no code? Is it one-click deployments? Like how do you map this space, right? What does it look like? What are the big trends?
So I always kind of like, once again, take it back to the software engineering framing. My favorite one to watch, I think, is probably the orchestration wars. I call it that. But in the open source world, you'll see like quite a few tools that are helping different people schedule and monitor their data and ML pipelines. So obviously they're the heavyweights like Apache Airflow, but they have been the rise of things like Prefect and Dagster to get into that war. And then there's also proliferation of tools in the monitoring space. It's actually become a bit interesting to see that there's too many tools, I think, at this point in time. And there are some standards that seem to be winning out, like our favorite project, MLflow, which we do know of quite a few users there. And then also in terms of thinking about robust frameworks for developing code as well, I do work on Kedro, which was now, obviously it was McKinsey's first open source project, but we've recently just shifted to the Linux Foundation's AI and data incubator. And I think there will be an increase in the number of frameworks we see that kind of create opinions about how people should be writing code, so that the code ultimately is more robust, so that it is easier to put into production systems as well. So I definitely do think monitoring, orchestration, and probably data related projects as well have also been in that space. And when I look at the data projects, I always look at, there's a group that's trying to solve data quality issues like Great Expectations, that basically say, please throw me an error if my data doesn't conform to specific standards I set. There's other projects that are looking at how can we fix the data, fully knowing that the data is a lot to fix and address, even if a human was supposed to be going through it. And then there's the third case as well, where we're obviously thinking about how we consume data for our ML platforms as well, which is where feature stores come in as well. So it has been quite interesting to see all of those different trends.
Maybe some additional from me, right? So I think on the technical side, I'm actually very excited about the movement to data-centric AI, right? The fact that that like more and more emphasis are given into the data quality, right? Like the importance of like having a proper data to fit into the machine learning algorithm. Because again, like when we look at the models, like we're probably going to move the needle from like 95 to 96, but really like when we are talking about data, right? There's so much things that we can do, which is the reason why I'm actually very excited to see like a lot of like data products being launched. Kedro, like I'm also like a big fan. Flight, like data aware pipelines, right? I think these are like some of the things which excite me, especially on the space. So that's on the technical side. On the kind of meta side, I would see like in the future, like some of these machine learning products actually will be commoditized by like the big names, basically, right? So they'll so I think more and more we're also investing in decision science, right? So knowing that we can codify business strategy, what will be then be the right strategy? Where we really need to kind of like crunch incomplete information and come up with some recommendation. Suppose, for example, I have a tools that can absorb my budget and can give me best recommendations to users, right? How can I then divide my budget, for example, like in the context of growth within activations, within maximization, retention, and stuff like that? So I think that will require different kind of skill set. Yeah, so that's my view.
Thanks for the notes. I mean, lots going on in the space. I think you guys have covered most of the, if not all of the key points, if that was possible. And we have about a minute left. What I picked up a little bit on was lots of changes, and this may also mean some changes for practitioners, the skills they should try to develop. So maybe with the 30 seconds left for each of you, like what do you see? What should practitioners be focusing on? What should data scientists be focusing on, for example, as we enter the next phase of where tools are scaling, and there's just so much development in the space. Any thoughts on that?
Maybe just two. So the one would be generally to, I think, try and upskill on software engineering best practices. There are quite a few courses that are online that can basically educate you on clean code principles for data science code, because you can even start to apply those things without the tools. And the second piece would be mark out where you seem to have problems in your workflows as well. Because that's a very easy indicator. If you have a list of those things, to actually source the right open source tool to actually help you solve that, or open source tool or product to help you address that, as opposed to, I think, just being shocked at how many tools there are out there and not knowing which one to pick and adopt and use in your organization.
Yeah. Just to complement the explanations, I think I would really suggest for future leaders to focus a lot on the problem-solving skill and first principles, right? Because in the future there will be plenty of tools, and one needs to really develop craft in order to understand which tools to use for which kind of a problem statement. I think that will be very precious skill set to develop in the future.
Yeah, I think we're about at time, and I think that was a great way to close our session. Thank you both so much for the time and insights. I'm sure everyone benefited from it, and I think that's the end of this fireside chat. Thank you once again.